You guys, your notes look different than mine because apparently I took these same problems and spaced them out, and I just don't have time to do that right now. So I'm just going to look at the problem. This is just for the benefit of people watching the video. So people like Taylor Willis or whoever, yeah, you're going to need a sheet of paper. People like Taylor Willis, you're going to need uh, your notes. It's the same problems if you look at it, so don't get confused, okay? So we're going to redo problem one, and you're going to follow on and watch because some of you were here and some of you weren't, and that will give you some indication. And then you're going to try some of your homework problems. So you might wonder what's a scratch sheet of paper for. You're going to get time today to complete some of your problems. Today is so important that you can um, finish the first few problems and make positive strides moving forward. Because then after that, you've learned the calculus. It's just a matter of learning the setup of the problem. That's what you're going to need. So, again, the first problem says a basketball is being filled with air. We did, and we're going to do it again. And you're going to look along to kind of follow along and see exactly how it goes, okay? You have this basketball, it's being filled with air. If a basketball is being filled with air, what shape does it make? A sphere. And I have this sheet of notes. Yep, that's exactly what we're doing, Amber. So this sheet of notes right here, this shows some of the formulas for volume and area and things of that nature. So what is the formula for the volume of a sphere? So in this box, I like to put formulas. I also like to put knowns and unknowns. So formula is volume is equal to 4/3 times pi r cubed. This one I like to model the problem. On this one, I like to take the derivative with respect to time. And this one I like to solve. So what else do you know in this problem again? It says that air is being filled at a rate of 1 cubic centimeter per minute per second. What is that? What is 1 cubic centimeter per second? One cubic centimeter refers to volume, correct? 1 cubic centimeter per second refers to derivative of volume. So known is V prime is equal to 1. Do you know the current radius? What is it? What are we trying to find in this problem? The rate at which the radius is increasing. So the unknown is r prime. That's what we want to be able to find. So what we do is we take this derivative, and for those of you who are gone, we are doing the derivative with respect to time of volume equals 4/3 pi r to the third. Now, Amber and Emerald, you see this time variable down here? Do you see time anywhere in that problem? So therefore, it's this implicit differentiation type idea, where the derivative of v is 1 times v prime. So you get v prime. The derivative of r to the third is 3r squared. So you multiply 3 out front, and then you have to attach an r prime. So you get v prime is equal to 4 pi r squared r prime. Is there now enough information to be able to solve? Yeah. What is v prime? 1 equals 4 times pi times 12 squared times r prime. We're trying to find r prime. Well, now we can. So we're going to divide by 4, divide by pi, divide by 12 squared, and we get is equal to r prime. We need a label. This is a rate. R prime is equal to 0.0005. What is the radius measured in? Centimeters. And since it's a rate, what is the time? Seconds. So that's what R prime is. Now, this is a very, very introductory problem to related rates. We're going to get much more complicated problems than this. What I want you to do right now is I want you to try problems 1 and 2 from your assignment. Your assignment is right here, These 22 problems, we're going to work on a few of them right now. It's so important that you can get through the first couple and get used to the process and set them up. You might even be able to do 3 or 4, but before we move on any further, I want everybody able to be able to do 1 and 2. Okay? Everybody good to go there? Okay, I'm going to pause this. Right now, what I'd like you guys to do is turn to the second problem in your notes. And let's see. Okay, problem 2. We're going to do 2 more problems together. I'm going to give you some more time to work. It says a right triangle has a base of 12 centimeters. Sorry, I didn't put that in there. That remains constant while the height and area increase. The area is increasing at a rate of 8 centimeters squared per second. At what rate is the height increasing when the area is 64 centimeters squared? Again, a difficult problem, but we can make it quite easy if we just set it up using our 4 boxes. I have a triangle. Is the base changing? The base is always what? 12. This part is getting bigger, and this part's getting bigger, but the base is staying the same. This dimension right here never changes, right? Sure, you could move down if you want to think of it that way, but it's always 12. It's not getting larger or smaller. Okay, so I'm going to write down a formula. Which formula should I write? Area equals 1/2 base times height. Okay? And knowns and unknowns in this problem. What do you know? A prime is equal to 8. The base is 12. The current area is 64. Our unknowns, what are we trying to find? The current area is 64. H prime is what we're looking for. Do you know the current height? No. Could we figure it out? Yeah, let's see if we need to figure it out first, okay? Before we try to figure it out, let's see if we need to figure it out first, okay? We take the derivative with respect to time. What's different about this problem compared to the other ones you've done? You have 2 variables on that side. So if you have 2 variables, what do we have to do? Product rule. So we hear some groans, and then we hear some people with excitement and enthusiasm. Megan was excited. Matthew groaned. So I have 2 functions. I have the one that's red, the one that's green. Let's use the chain rule, or the product rule. What's the derivative of A? A prime. What is the derivative of 1/2 B? 1/2 B prime times H plus 1/2 B times, what's the derivative of H? H prime. Is everybody okay with that derivative? All right. Let's look at this. B prime. We don't know that either, do we? We don't know H or B prime. Let's think about B prime first. We know we can find H, but let's think about B prime. B prime means the rate at which the base is changing. The base is not changing, so it's 0. So you do know B prime. You just didn't realize it. It remains constant, so it does not have change. Very good. So what is A prime then? Okay. In the problem, Sini, it says that a right triangle has a base of 12 centimeters that remains constant. Therefore, it's not getting any bigger. It's not getting any smaller. So at what rate is it changing? The change is 0. It's not changing. Right, the derivative would be 0 of that. All right, so a prime is 8 is equal to, if b prime is 0, then that whole piece is 0, correct? Equals 1/2 times, what is the current base? 12 times h prime. Or 8 is equal to 6 h prime. Divide both sides by 6. 4 over 3 is equal to h prime. Or h prime is equal to 4 over 3 what? It is a rate, so we must attach centimeters per second. Is okay? All right. Next problem. Problem number 3. Two cars leave an intersection at the same time. Car A is driving north at a rate of 40 miles per hour. Car B is driving west at a rate of 30 miles per hour. At what rate is their distance apart increasing after 1.5 hours? Car A is going north. Car B is going west. That's their distance. We're wondering the rate at which the distance is increasing. Hi. What's our unknown? B prime, right? What is the equation that you use to relate A, B, and D? Very good. A squared plus B squared is equal to D squared. What are your knowns? A, now we don't know A yet, but we know A prime. A prime is 40. B prime is 30. So Kimball's right. If they've been traveling for an hour and a half at 40 miles an hour, how many miles have they traveled? 60. And 30 miles an hour for an hour and a half would give you 45. 1.5 hours times their rate. So distance equals rate times time. Yes. Now, we don't know D prime. That's what we're trying to figure out. But can you figure out D? If A is equal to 60 and B is equal to 45, please quickly try to figure out for me what is D. On your calculator using the Pythagorean theorem, you come up with, very good, 75. All right. Sorry, we all make mistakes. I'm recording, all right. So we're going to now take the derivative with respect to time. What's the derivative of A squared? Say it again. Close. 2A prime plus equals Look at it. Yeah, there's 6 variables. How many do we know? No, 5. So 2 times 60 times 40 plus 2 times 45 times 30 equals 2 times 75 times d prime. You get 50? So there you go. All right, so here's what I want to do, folks. It's up here, but really quick, let me give you kind of what you can work on right now, and then we can look at the answer sheet. All right? There's 22 problems. I want you to be able to do the very basics, which were problems like 1, 2, and 3. Right now, you should be able to work through, and again, you guys, I know I could give you, like problem 1, area of a circle and radius. I know I could give you 20 problems like that. You'd be able to do them all. Question is, can you do it if we just change a little bit of the problem? So you should be able to do 1 through 6. Nope. 10 through 12. Just kind of, no, no, not 7 through 9 yet. 10, 11, and 12 have just a little trick to them that we'll see if you see. And then finally, problem 16. Yeah, go ahead. 17 as well. Go ahead. I don't care. Do it. Yep. Um, sure, you can try 17 as well. Use the law of cosines. See if you remember it. So, go ahead. It's very important that you stay on top of this because we're not going to, spend 2 weeks on this and then review. We are going to do our homework and then we're going to test. I don't know for sure, but I would say right now, I kind of like the idea of Monday. Yeah. That way we would have 2 weeks before Christmas break to do some other stuff. We would get through a lot of chapter 4. So that's where you're at, folks. Good luck.